Hello, welcome to another video. In this opportunity, we're going to talk about some tips on how to draw a bicycle wheel in perspective. As we explained on a previous video, the circle of the wheel becomes an ellipse when we are looking at it in perspective. However, depending on your view, the ellipse is going to change. But before we explain these changes, let's review a little bit about the elements of our ellipse. One of the first elements of the ellipse is the minor axis. If we imagine our ellipse as part of a cylinder, then the minor axis will be like the spine that goes through the middle, and the major axis will be just another straight line that crosses perpendicular to the minor axis. This is very important. Always remember that the major axis is always perpendicular to the minor axis. Now, let's talk about eye level. Another element to consider is eye level, which is the actual height of the viewer's eye when looking at an object. For example, here we're looking at the bike from above. The eye level is above the bicycle, while here we're looking at the bike at ground level. Our eyes are at the same level as the bicycle. Having this in mind, let's see how, depending on our eye level, our ellipse changes. Let's take a look at the wheel of my bicycle in perspective. Here you can see both the minor and major axis. In the first picture, we're looking at the wheel at a ground level. And as you can see, the endpoints of the ellipse align vertically to form the major axis. But as we start changing our view, and looking at the wheel from above, we can see clearly how the major axis is no longer vertical, and the more our eye level rises, we can see the major axis slanting more and more. But why does this happen? Well, let's take a look at these three boxes. If we put an ellipse on one of the sides of each of the boxes, we can see that if we look at the wheel at the street level, the minor axis is horizontal. Thus, the major axis aligns vertically because, remember, the major axis is perpendicular to the minor axis. If the minor axis is horizontal, then the major axis will be vertical. But if you want to pick a view in which you are looking at the ellipse from above, then the minor axis is going to tip. And because the minor axis tips and the major axis is always perpendicular to the minor, we need to adjust accordingly. The same thing happens when we change to a warm eyes view, looking at it from below. In conclusion, to make things simple, before we start drawing our wheel, you want to pick up a view. If you're looking at it from above or below, draw the ellipse slanting towards one side or another depending on your view. If you're looking at the wheel at the same ground level, then draw the ellipse vertically. Point number 2, shading. Now, if we see this bicycle, we can see that the bicycle frame and the handlebar and even the saddle has some defined shadow and light areas. However, we cannot say the same thing about the wheels. They actually look quite simple. If we want to improve our wheels, we need to take into account shading. What I mean by shading is adding some values to the tire to make it look rounded. It doesn't have to be too complicated. Just taking into account the two main zones of light and shadow will make a huge impact. A quick note here, I'm still learning about shading at this moment, but I would strongly recommend watching Prokos Shading Basics. It will help you shed a light on this topic. I will leave the links to the two videos in the description. Now, moving on. Considering the light source coming from above in this direction, we can easily place the core shadow, making sure it has soft edges. If you're using Photoshop, you can make the edges soft by either adding some feather to our selection tool before filling it with color or by selecting a soft brush. Either way, the important thing here is to make sure that it has a soft edge. Why is this so important? Because when drawing cylindrical objects, the transition between light and shadow has to be soft. Otherwise, it would not read as a cylindrical object. It would probably read more as a cubical object. Here you can see an example of shading where the more cylindrical the surface, the softer the transition between light and shadow. Again, this is better explained in prokos video. The links will be below. And this is our video for today. Thank you for watching. If you like this type of content, you can support this channel by subscribing and giving thumbs up. See you on another video.